Hello everybody, hope you're all doing well. We're going to continue on with our unit on exponentials. So I have a do now for you. It's to write the equations for the following exponential graphs is what we've been working on the past couple of days. So take a second, pause and try it. And then when you unpause, I'll go over it. Okay, so the first one, I want you to realize that it's an exponential growth, and we can tell that just by looking at the way the graph goes. The graph is going in an upward direction. That means that it's exponential growth. Okay, so what we're going to do to figure out how to write this equation is we're going to make ourselves a table, and we're going to look at some points. So remember, you want to look from left to right. So the first x value that I see that's a nice point to look at, that would be here, is 0, 5. That's also our y-intercept, so that's going to be very helpful. And then as we continue on to the right, the next point I see is 1, 10. So I'm going to write that there. Okay, so I know that it's got this form where a is my y-intercept, so that is going to be the 5. So y equals 5, something to the x. And then I need to figure out the multiplying factor. And it's called the multiplying factor because I'm asking myself, what am I multiplying to get from 5 to 10? 5 times what is 10? Well, that's 2. So here is my formula for that one. And then let's look at the second one. This one is a decay since the graph is going down. You always want to look for your x values from left to right. So even though I see the point 0.2, here's the point 0.2, I can't write that yet. The first point I need to write is negative 2, 8. Then I'm going to go to the next point I see to the right of that, and that's negative 1, 5. Oh, sorry, 4. Negative 1, 4. And then 0, 2. So now that my x's are in order, they're going up, negative 2, negative 1, 0, I can look at my y's to figure out my multiplying factor. 8 times what is 4? 4 times what is 2? If you're not sure, do 4 divided by 8 or 2 divided by 4. Either way, you're going to get 0.5 or 1/2. So the equation of this is y equals 2, because that's my y-intercept, parenthesis 1/2 to the x. Okay. I left you a little blank spot. I want to do just a little recap of what we've talked about so far with exponential growth or decay. So we have exponential graphs or exponential equations. I'm just going to call them exponentials. And they have this format where A is my y-intercept and B is my multiplying factor. Okay. If B is greater than 1, do you remember what it is? It is exponential growth. If B is less than 1, then what is it? Yep, it's exponential decay. Okay, so that's what we've done so far. We're going to take that one step further today. And we're going to take a look at some formulas for exponential growth and exponential decay. So this is kind of formally how they might be written, maybe in a textbook with an A. We can kind of do it like this, because that's what we're used to seeing. So we'll look at the formulas this way in the blue. Okay, A, I'm going to cross these out. Let's not look at it this way. No need to confuse us. A is still your y-intercept. So whatever you have, the number in front of the parenthesis is still going to be your y-intercept. The number in the parenthesis, this either 1 plus r or 1 minus r, is still going to be your multiplying factor. Either way, it's still going to be your multiplying factor. If we're adding something, it's growth, and if we're subtracting something, it's decay. So the r inside the multiplying factor stands for the rate. So the rate we might be talking about if we're doing a question on money, maybe we're earning some interest, or maybe bacteria are multiplying at a certain percent. It's going to be the rate expressed as a decimal, and t tends to be time. If we're talking, when we do these word problems, we're usually talking about time, and the exponent where we've normally put an x, a lot of times we're going to see it's a t just because we're talking about time and it's easier to say t. Okay, so let's take a look at some problems. Okay, so this says, is the equation a equals 21,001 minus 0.12 to the t a model of exponential growth or exponential decay? Okay, well, we have to remember this is growth, and this is decay. So right away, I see a subtraction, 1 minus something. Well, that's going to tell me that it's decay. So I can cross out choice 1 and I can cross out choice 2. I'm subtracting whatever the rate is. Okay, so it's 1 minus r. So 1 minus r, well, they're telling me that's 1 minus 0.12. So the r must be 0.12. That's the rate as a decimal. How do we get from a decimal to a percent? How do we get from a decimal to a percent? We move the decimal place over 2 spots, or we multiply it by 100. Either way, that's doing the same thing. So move it over 2 spots, and it's 12%. If you had, that's the end of this question. If you had simplified this a little bit, and you actually in your calculator did 1 minus 0.12, you're going to get 0.88. Another way to think about it is 0.88 greater than 1 or less than 1. 0.88 is less than 1. So that must mean that this is decay, just like we found it to be decay. Okay, let's go to our next question. Mr. Smith invested $2,500 in a savings account that earns 3% interest compounded annually. He made no additional deposits or withdrawals. Which expression can be used to determine the number of dollars in this account at the end of 4 years? Okay, so something you need to know for this lesson today is a little bit about interest. Interest is money that the bank gives you. They add it on to the money that you put in. So if you go to the bank and you put in, well, like Mr. Smith, he put in $2,500. The bank is going to give him interest on his money. They're going to give him like extra money. And they're giving Mr. Smith 3% interest. So that's going to be exponential growth because he's adding on to his money. So here's my formula. A is my initial amount. So it's whatever I initially invest. So Mr. Smith invested $2,500. His rate is 3%, 3% interest. We need to take that percent and make it into a decimal. So percent to a decimal, we divide by 100 or move the decimal over 2 places. So if you want to take that 3 in your calculator, divide it by 100, you're going to see that it is 0.03. 0.03 is 3% expressed as a decimal. So that's going to be 1 plus 0.03 to the t, and then they tell us that it's 4 years. So again, I want to just make a note that I'm adding because it's money and we're getting interest on our money. Interest shows that I'm adding on. That's what happens with interest. So I could have crossed out 2 and 4 because those are both subtractions. And choice 3, 0.04, that's not right. We're looking at the percent. That's how much he's getting. So it wouldn't be, that's 4%. We'd want the one with 3%. Okay. Sam bought a used car for $8,000. He boasted that he got a great deal since the value of the car 2 years ago, when it was new, was $15,000. His friend Derek was skeptical. He wasn't sure. His friend Derek was saying, I don't know, stating that the value of a car typically depreciates 25% per year. So Sam got a bad deal. Well, depreciates means goes down. A lot of vocab in this unit. Depreciate means it goes down. So if I buy something new, like a car or a boat, maybe an antique, could depend. A lot of times those depreciate. Especially we talk about this a lot with cars. If you buy a new car, it depreciates. Its value goes down. It's exponential decay. When you see that word depreciate, that means that the value is going down. So it's exponential decay. So I know in part A, I'm going to do it down here. I need to use my exponential decay formula. Okay? Where again, A is my initial amount and R is my rate as a decimal. Okay? So we want to use Derek's logic, Derek's the friend, to write a formula for the value of Sam's car. So I want you to ask yourself, again, what is the A? What is this A here? That's your initial amount. So we're not going to put the 8,000 in. We're going to put the 15,000 in because that was the value of Sam's car when it was new. We want to put the initial amount, the amount when it was new. And then I want to do 1 minus R. Now the rate is 25%, but I need to do that as a decimal. So again, decimal 2% divide by 100. So 25% divided by 100, 25 divided by 100 is 0.25 to the T. So that's just a formula for the value of Sam's car. T is time in years. So I could put in 1 year later or 2 years later or 10 years later to see what the car would be worth. Okay, part B says determine who is right, Sam or Derek. Justify your response. So part B, they want us to figure out how much maybe Sam should have paid for his car. He paid $8,000. He thought he got a great deal. But according to Derek, the car should lose 25% a year. So Sam bought the car 2 years after it was new. So we're going to put 2 in for T. Okay, what I want you to do is I want you to go to your calculator and I want you to type this in. So when I type it in, I get 8437.5. So let's just analyze this. Let's think about this for a second. Sam, before he had the car, 2 years ago when it was new, it was worth $15,000. Okay, so 2 years ago, it was $15,000. Okay, according to Derek's claim, now it should be worth $8,437.50. So did Sam get a good deal or not a good deal? Did Sam pay more or less than the car was worth? Sam actually got a good deal. Sam paid less, according to Derek, Sam paid less than he should have. So Sam got a good deal. Sam was right. Okay, let's take a look at the next question. A car depreciates at a rate of 4.5% annually. Now, depreciates, that's one of those vocab words. They tell you here that it loses value. Loses value, so that means I'm going to need to use decay, exponential decay. Greg purchased a car for $12,500. So ask yourself, where should that $12,500 go? In for A, because that's the initial amount. 1 minus R. Well, R is 4.5%. But again, I need to put it as a decimal. So 4.5 divided by 100. Just simply pop that into your calculator and you get 0.045. And we want to know after 5 years. Why 5 years? That's just the number of years that they picked. Okay, so that's it. Maybe they might ask us what it's worth, but they didn't actually do that in this case. They just wanted us to write the equation for it. So let's find which one matches. Oh, we're not sure. Okay, so what they did here, simple thing, was they decided to simplify this. They did 1 minus 0.045 just to kind of clean it up. It's a little harder to see what's going on in this case, but I want you, well, let's pick the answer and then I want to point something out. So it looks like it is choice 2. Okay, I do want to point out one thing to you. If you notice, we have a subtraction sign. That would mean decay. And we also have this 0.955 when it's simplified. That also shows decay because it's less than 1. When it is less than 1, it shows decay. 0.955 is less than 1. So either way, whether you see it in the unsimplified way, that's the highlighted in yellow, or the simplified way, the 0.955, either way, it's decay. And it's decay because the car is depreciating or losing value. So get another one. Daniel's print shop purchased a new printer for $35,000. Each year it depreciates, there's that word again, loses value at a rate of 5%. What will its approximate value be at the end of the 4th year? Okay, so if it is depreciating, is that decay or growth? That is decay. Okay, so we need that formula. I wouldn't worry about memorizing the formulas, but I would kind of worry about just knowing what they are, being able to find them. Okay, so this is exponential decay. And let's set ourselves up an equation. A is my initial amount, my purchase price. So that's going to be the $35,000. 1 minus, well, that's my rate. My rate is 5%. Again, I need to make it a decimal, so 5 divided by 100 is 0.05. And then they just happened to pick a random year. They wanted to know what's the value of this printer at the end of the 4th year. So I'm going to put 4 in for T. If they ask me at the end of the 7th year, then I would put 7 in. Just depends whatever they're asking. Okay, so type that into your calculator. Give you a second to do that. We do get a number 28,507.71875. Now it's not an issue at all. We can see that it is choice 3. They rounded for us, but keep in mind if we're talking about money, we should round to 2 places. So that's, I want to go to 2 places. So I'm going to look at the 8, and the 8 makes the 1 round up to 2, so 72. Okay. Just one thing that should kind of to keep in mind, the original price of the printer was $35,000. Now it's worth $28,000 or $28,507. It did go down because it depreciated. That's what happens with depreciating. The amount goes down. Just like I said, if you were to buy a new car and then in a few years go to sell it, the car is going to be worth less money than it was originally. It's just the way it works. A lot of times things end up being worth less after a few years. Okay, let's take a look at just a couple more. I think that's all we have for today. A few more. The current student population of the Brentwood Student Center is 2,000. The enrollment at the center increases at a rate of 4% each year. So now, if it's increasing, growth or decay? Growth. So let's fill this in. The current student population, that means the initial amount, is 2,000. 1 plus, I need to do 0.04. 4% divided by 100 to get it into a decimal is 0.04. And then we want to know in 3 years. Should it be more or less? I guess we could tell just by looking at the choices, but it should be more than 2,000 because the population is increasing. So if it started at 2,000, it should be more after that. So 2,000 times 1 plus 0.04 to the third. Okay, so that's what I got. Let's look at what the closest choice is, 2249.72. Well, we're talking about students. We can't have part of a student, right? So we need to round to the nearest whole number, 2250. Okay. The value of a car purchased for $20,000 decreases at a rate of 12% per year. So this is nice. They don't even use the word depreciates. They just tell you that it decreases. So that's decay. What will the value be the value of the car after 3 years? Okay, so why don't you pause, try it, and then I'll do it when you come back. Try it on your own. Sorry about that. Okay, so we have exponential decay. So 20,000 is the initial price. That's the A. 1 minus the rate is 12%. I took 12 and divided it by 100 and got 0.12. And then they asked me after 3 years. You know what? I actually want to show you typing it in, just in case you're not sure how to do that part. So, oops, I forgot what I'm typing in. I'm sorry. 20,000, 1 minus 0.12. Okay, so just in case you're unsure how to type it in, 20,000, parenthesis, 1 minus 0.12, and then I need to raise it to the, is it 4 years? 3 years. I need to raise it to 3 years. So you're going to use that button right below the clear. I can't really point it out on my screen, but it's below the clear above the division. And I already forgot how many years. I'm sorry about all the switching. To the third. Okay. So 13,629. Here we go, choice 2. On a side note, if you, for some reason, don't have your calculator, I believe that there is one available to get online for free. Actually, you could get the one I have. It's called Taculator. Looks just like ours. I believe you can also get a version of ours, the TI-84, online too, just in case someone doesn't have their calculator. Okay, I have one more to do with you, and then I want you to try just one totally on your own. The value Y of a $15,000 investment over X years is represented by the equation, and they give us this equation. Okay, this is nice, actually, because they give us the equation. We don't have to do anything. All we have to do is plug in 6. they tell us that X is years, and then they tell us to plug in 6. So let's type that in. Just do 6 divided by 3 in your exponent. And there we go. Okay, there's one more question. I labeled it an exit card. Please do that one and try it. If you can't get it, that's okay. But do that one and hand in all your notes. Okay? All right. Bye, everybody. I miss you all.